My brother has found a great new investment opportunity at the bank. The bank tells him that if he puts in £1 with them at the start, by the end of the second month he will end up with £2. And then by the end of the third month he will end up with £4. So according to this logic, by the end of the fourth month he will end up with £8. The real question is, though, by the end of how many months will it take him to reach £1,000,000? Today we'll uncover the fascinating world of logarithms, a concept that revolutionized mathematics. We'll explore their history, understand the basics, and see their practical uses in modern times. What are logarithms? Logarithms are the inverse of exponentiation. If exponentiation tells us the result of raising a base to the power, logarithm tells us the power needed to get its specific result. For example, the logarithm base 2 of 8 is 3 because 2 raised to the power of 3 is equal to 8. Let's look at some calculations to understand why mathematicians in the past used logarithms. Starting with an easy equation, what is 2 times 3? We can all confidently answer that it's 6. But what about larger numbers, such as 12 times 23? This would probably take you a longer time, maybe 2 minutes, which doesn't seem that long. But let's say we had an even larger number, such as 123,456 times 654,321. To save you the time to actually calculate it, the answer is 80,779,853,376. Now, that's a mouthful to say, and even more of a exercise to try to calculate it without using a calculator. However, the mathematicians in the past, they had to work with even larger numbers. So how do you think they did it? Before calculators, mathematicians faced tedious calculations. In the 1600s, John Napier, a Scottish mathematician, introduced logarithms to simplify these tasks. He sought a ready art to overcome the tedious expense of time in calculations. Napier's logarithms transformed multiplication and division into simpler addition and subtraction, greatly speeding up complex calculations and reducing errors. These long and tedious calculations were simplified using Napier's log tables. Mathematicians converted multiplication and division into simpler addition and subtraction. They could easily multiply large numbers by converting them to logs, adding the logs, and then converting back. This method was particularly useful in astronomy, navigation, and engineering, where precise and complex calculations were essential. What are logs for used in this day and age? Logarithms help us manage very large or small numbers, like the Richter scale for earthquakes. This scale uses logarithmic function to quantify the energy released by an earthquake, making it easier to compare events of vastly different magnitudes. In biology, logarithms describe exponential growth, such as bacterial population doubling over time. In finance, compound interest calculations rely on logarithms to determine how investments grow over time. And in computer science, logarithms are used in algorithms to handle data more efficiently. For example, in search algorithm and data compression techniques. Despite calculators, logarithms remain fundamental in understanding exponential growth and decay. They help us comprehend the spread of disease, population dynamics, and even the complexity of algorithms. Learning logarithms enhances our comprehension of mathematical relationship and real-world phenomena, providing insights into how different variables can interact and change over time. What are the different ways we can convert numbers to logarithms? The first way we could use are calculators. Modern calculators have logarithm functions, usually labeled as log for base 10 or ln for the natural logarithm. You simply enter the number and press the appropriate button to get the logarithm. Or you could also use logarithm tables. Before calculators, people used logarithm tables. These tables listed numbers and their corresponding logarithms, allowing quick lookup. For instance, you would find the number 1000 in the table and see that base 10 logarithm is 3, because 10 to the power of 3 is 1000. Lastly, you could also use mapping as software. In the digital age, software and online tools can quickly convert numbers to logarithms. These tools are based on the same principles as logarithm tables, but are far more convenient. Logarithms have such a rich history and are essential in many fields today. They evolved from simplifying tedious calculations to being integral in modern science and technology. If you found this video, please like and subscribe for more insights into the wonders of mathematics. Thank you for watching.